Hello and welcome to the Llama Podcast. I'm Peter Bowes, and Llama, Live Long and Master Aging is where we explore the science and stories behind human longevity. This is week 2 of our podcast, and first of all I want to thank everyone who's listened to the launch episodes 1 through to 3. They provoked some debate and I appreciate your emails and questions, so please keep them coming. If you want to get in touch, you can do so through our website at llamapodcast.com. Now, today's guest, Dr. Nir Barzilai, studies some of the oldest populations of people in the world to try to understand the biology and genetics of exceptional longevity. One of the key questions being, are some people born with protective genes that delay aging and protect against age-related diseases? Dr. Barzilai holds multiple positions, including Director of the Institute for Aging Research at Albert Einstein College of Medicine. Well, we met at the annual TED Med Conference at La Quinta in California, where Dr. Barzilai gave a talk about drugs that could target the process of aging and help us live longer, higher quality lives. Here's the interview. Nir Barzilai, welcome to the Llama Podcast.
Thank you. Nice being here.
Let's go back to the beginning, to the time that you first realised that you were interested in this area, that the science of aging was something that intrigued you.
Yes, they say that children have a great imagination. And when I was a child, I walked with my grandfather. I was 13 years old. My grandfather walked with me every weekend and told me about his history. And I looked at this old man and I said, there's no way that you did what you said you would do. It was very intriguing to me. And most children, when I talked with my friends about it, they didn't, they think grandparents are born that way. They didn't understand the transformation or that it's actually important to understand that. And somehow it was something that captured me. And through medical school and through my internship and everything, I was really drawn to understand really the process of aging and what the hell is going on there, and can we do something about that? So it came early on and it stuck.
It came early on in part through observing elderly people and how they are and how they behave and how they've got there.
And how they looked, the biology was really the fascinating thing. What happens that the hair gets like that and the skin gets like that and the tummy, protrudes and all that? It was, they definitely didn't start like that, but it took time to realize that.
And was it something as a young man or even as a boy that you wondered how you could change things or slow down the aging process, or perhaps do something so the body didn't look like that, or the frailty that comes with old age?
I would love to say that I thought that way, but I don't think that when I was a child I thought of my capacity of being scientist and targeting that. In fact, this is one of the greatest things in life, that you get there and all of a sudden you do that. But it's only the curiosity about aging that I remember.
So you became a scientist. What aspect of aging so fascinated you that you wanted to do something about it?
It became clear to me that aging in the hospital is associated with age-related diseases. And it didn't matter which disease the old person had. It could have cancer or it could have heart. And later the realization that really the death from the risk of death from any disease by aging is a greater risk than any specific risk factor for any disease. If you get heart attack, if you have more chances of getting heart attack when your cholesterol is high, this is really nothing risk compared to the risk of aging, which is hundreds and thousand-folds. And the same for cancer. For cancer, it's also 1,000-fold when you age. And you can go through diabetes and Alzheimer and see that age is the major risk factor for the disease. It's the common risk factor for the disease. And then you realize that if you don't target aging, all that you can expect is to exchange one disease with another. And that's not going to be a major progress, and it's not going to be so good for the patients either, who are going to survive one disease and get the next.
And this is the great paradigm change, isn't it? That people are beginning to acknowledge essentially what you have just said, that it is aging per se that needs to be researched and examined and acknowledged before we can do something about those deadly diseases.
Right, and I think what we discovered is aging has biology, and it's different than the biology of the young. And second is that once we discovered this biology, we've been successful in targeting aging in a variety of animal models.
And of course, some people will listen to this and say, well, of course, aging is inevitable. There's nothing more inevitable about tomorrow happening and the next week and the next year. That is just how life is. But you're not talking about aging in years and numbers. You're talking about it in a much deeper sense.
You know, we can talk about aging on many levels. For me, the major question is the discrepancy between chronological age and biological age. This is, for me, is the problem that we're trying to solve across species, in humans, across treatments. So we can talk about aging through other lens, but this is the lens that is practical for me to think of, that there are models that we could look at and we could start dissecting or paving the road of how do we deal with it.
So tell me about your studies and some of those models that you've been looking at. You've been examining and researching a number of different populations, haven't you?
So one of the things that we've done is we have two studies in which we collect families of centenarians. One is a study where we really collect the centenarians themselves and their families, and another is taking offspring of centenarians and matching them with age match control and looking prospectively how they age and how their genetic influence the rate of their aging. And those two studies together are really showing us a lot of what's going on, at least in humans. Because in this study, we could look at their effect of their environment and their food and their exercise and their genetics on variety of outcomes that are including diseases, cognitive function, and other outcomes that we can link and find mechanisms.
And to what extent do you think longevity is linked to genetics versus external factors, the environment?
This question for me that comes in, this is a question that's relevant to obesity and almost everything, and it's always a fight between how much is the environment and how much is the genetics. And I think philosophically, we're here on this earth with our genes and this environment. And it's a collaboration, no matter what. The advantage of taking 100 years old, that at least the way it came out in my study, is that they are not claiming any interesting interaction with the environment. They were obese, they smoked, they didn't exercise, and they have other stories that they tell me that's why they live longer, but it doesn't make sense, like they ate lots of animal fat, okay?
Well, you hear this all the time, and there are often newspaper stories, television stories about people who reach a great age. And the question is always, what is the secret? What's the secret of your longevity? And you hear a different answer every time. It's, I eat 3 eggs a day. I eat lots of chocolate. I don't exercise, or I do a lot of exercise. I go for a bike ride every day. The explanation seems to be...
opposite of what you expect.
Counterintuitive, not what you think. Yes.
Right, and I think that's the point, because at this, you're asking, this effect between environment and genetics. I think the centenarians is a group that let us really focus on the genetics more, because basically they didn't interact with the environment so well, and still they live to this age in spite of that.
So do they have, it is often referred to as the longevity gene?
Right. They have longevity genes, and those are genes that we are finding. We are really working on the ones that have a chance to have functional consequences. and that they're modulating some pathways that are helping them to get to much older age.
So what are these pathways?
Let me give you several examples. We were really noticing that it wasn't their LDL bad cholesterol, but it's their good cholesterol, the HDL cholesterol, and sometimes the triglycerides that were better than expected, and sometimes they were really very high. To give you an example, HDL in elderly women is usually 55, but we have a woman who has 142 HDL, a centenarian. So
that's a huge number.
So we got, large numbers and huge numbers that suggested that we should look at lipids.
And presumably low triglycerides?
And low triglycerides. And we found 2 mutations that had functional consequences in our centenarians. And the interesting thing with those mutations is that 2 different pharmaceuticals have taken each one of our discoveries and decided that that means that it's safe to target those pathways because they're going to have drugs that will do that. So if you have a drug that does it, all the pharmaceutical wants to find the people who have it naturally and see if it's safe for them. And of course it's safe because we have it more in 100 years old than in control people. Almost none of our control have those mutations, and it's all in centenarians. So they're developing those drugs, but they're developing those drugs for a certain disease. In this case, it's cardiovascular disease. Although one of our discoveries that is in a gene that's called CETP, that is a major controller of HDL cholesterol, the most important discovery is not the cardiovascular protection, but the protection against cognitive decline. Not only does it protect against cognitive decline, and it was validated by other populations, but it protects from cognitive decline in subjects who have the ApoE4 genotype, that are the ApoE genotype. If you read the textbook, you're demented at 70 and dead at 80. And they're alive and not demented at 100 years old, but they all have this other genetics of the CETP that we think is important for them in order not to get the Alzheimer's. So what I'm trying to say is we're looking for genes. If it's against one disease, it's fine. It's going to be a nice discovery. But we really are trying to look at things that control the rate of aging, okay? Or protects you against aging in other ways. And so if we're finding that there's a genetic mutation that protects you from cardiovascular disease and dementia and cancer, this is exactly what we're looking for.
And what proportion, what percentage of the population do you think have these longevity genes? I mean, it's very rare to get to 100 years old still, isn't it?
Right. So that's exactly our approach. We're taking control population, and then we're taking centenarians, and we want to see if the mutation that we're finding in centenarians are overrepresented in them. Okay, so for example, the CETP mutation is in the homozygosity is about 8% in the population and goes to about 28% in centenarians. So it's really overrepresented. It makes you think that that's why the people got there, because there are many more of them with this mutation. We have another mutation in ApoC3 gene that is controlling more triglycerides and HDL, and this is in the promoter, so it also has a functional consequence. It's been shown in several populations to be relevant to aging and survival. By the way, this inhibitor for the ApoC3 is by a company with the unfortunate name of ISIS. But their antibody against the ApoC3 is very powerful.
It is true, isn't it, that longevity is, if you have it in your family, if your parents live to a very good age and their parents, and you have a sequence here that you can define, that you stand a better chance than most yourself to get to a ripe old age as well. So to what extent is longevity inherited? Is it possible to put a number on it?
No, you know what? It's not possible to put a number on. It's a strong effect, but it's not effect that is in a log scale in our hand. Okay, it increases. So I'll give you an example. If your grandfather had exceptional longevity, what's the chances that his son will have exceptional longevity? It's 7 to 9 times more than normal. Okay, it's substantial. It's better than the cholesterol story, but it's not, it's not 100%.
It's not a given. It's not definite.
And it's important that you ask that, because I once was interviewed on television, and on the way out, I went to fetch some food, and a guy was sitting there in a bar and said, "Were you just on television?" I said, "Yeah." He said, "You changed my life." I said, "How did you change my life?" He said, "I was in the gym exercising when I heard you, and I realized my grandmother is 103. I don't need to exercise ever again." So no, the answer is we don't know. We don't know. Continue to exercise. Maybe in the future we'll have some genetic prediction of longevity, but we're not there yet. And so interact with the environment.
And does it matter whether there's longevity on your mother's side or on your father's side? Does it make a difference that if your mother lives to, or your grandmother lives to a ripe old age, does that affect you in a different way to if it was on your father's side?
There are different ratios, but they're not great enough to tell you about it. I would say that generally you have better tendency to get the longevity from the mother than the father. But it's really complicated because there are more women who get to age 100 than to men. So it's actually very hard to determine exactly that. But in the space where we're living, the mothers have better chances to give you the longevity than the father.
So you are by studying centenarians or supercentenarians, do you think studying the best available population? Because I think one of the problems of anyone studying aging is the very nature of aging, of trying to get a group of people together that you can monitor over a long period of time. Science changes and all sorts of other political issues. The funding of science makes it difficult to study people over a long period of time. So by focusing on these centenarians, is that your best bet, do you think, to try to fathom this out?
Somewhat, yes. So look, I think the major stride that we've done in the field is not describing the biology of aging, but finding models that live longer. That really gave us the big opening. Caloric restriction increased lifespan, and dwarfism increased lifespan, but then drugs are increasing lifespan. And I think through those, we really learned a lot. And that's why I thought it's very important not only to go to the models that are living longer, to the animal models that are living longer, but to find what would be the human equivalent of living longer. Now, at the time that I did that, it wasn't, like all of science, nobody clapped hand to begin with. They thought, some people were hostile and said, this is nonsense. But what the state of the art was, what people studied then are people with progeroid syndromes that are aging very rapidly. And the thought was that you can learn from aging there. But in my mind, at that time, it was also, we knew from other models that, you can futz out things all over the place and do something that is not necessarily relevant to the clinical situation of humans. You can form diabetes by many ways in animals, but you don't find those genes in human diabetes. So the fact that there are people who are aging fast means that something really bad is happening, but it doesn't mean that that's why we age, because of those same genes. And by the way, we found in our centenarians that some of those genes of progeroid are playing a role in aging. So it's not that they are completely wrong, but we're after the genes that will be the longevity genes and not really the aging genes. And
so do you think we are moving towards a time where we can essentially replicate what those longevity genes are doing for certain people? Replicate that through drugs, through diet, through perhaps calorie restriction or fasting, that it will be a combination of interventions?
I think it's possible. Look, let's take a drug like metformin. The metformin is a drug that you give to animals and they live longer, not the longest of any drug, but they live longer. But what's more striking, they live healthier.
And this is the diabetes drug?
That's the diabetes drug. If you look at what metformin is doing in relation to what we know about aging, some pathways like, I'm just saying, mTOR and sirtuins and AMP kinase and insulin action and inflammation.
You mentioned a lot of long phrases there. mTOR, what is that?
mTOR is a nutrient sensing that is considered one of the major intervention that can enhance lifespan in animals and in variety of animals. So it's after metformin, it's the best hope for the first drug in the future. It's just not safe the way it is now. You cannot take it chronically because in human it causes diabetes and cataract in animals and testicular atrophy, things that you don't necessarily want. So, but if this is what we're going to do, it's going to get to be a better drug, and then you can use them in combination. But I digressed. What I wanted to say about metformin, because we're talking about mechanism, and we have to get used to it. I have evidence that metformin affects all those words that I mentioned, okay, before, mTOR and this and that. Affects everything. And so what is it? It's a super drug that happens to target exactly the right thing.
And it's been around for a long time.
It's been around, yeah, it's been 60 years.
So
we
tried
don't know,
and tested and safe in that respect.
But by the way, just a really interesting thing. I was a fellow in Yale at 87, 88, and my project was to find the mechanism of action of metformin that is relevant for diabetes. And so I was one of the first to do that and to publish that, except that I left metformin behind and metformin came to me later.
So at that stage, no idea, no concept that it could affect longevity?
No, absolutely not. It wasn't even clear then if it was safe. There was a lot of worry that it had a cousin by the name of fenformin that caused trouble, so it wasn't clear that it's safe. So those years, it's 30 years ago. So we know much better now. But what I really am trying to say that metformin seems that it affects everything that we want to go away with aging, and I think the reason it does is it actually fixes one thing. But once you fix this one thing, everything else, okay, the whole aging phenotype goes away. In other words, with aging, when you see drugs are correcting many things, you don't have to think about them as targeting many things. It's just correcting the aging. And that's why I'm optimistic that metformin is really a good drug from a human perspective because it does all those things.
This is a drug related to diabetes. This is why it's prescribed. It's not prescribed as a longevity drug now, is it? So people listening to that thinking, well, maybe I should try metformin. I don't have diabetes or diabetes-related issues. What would you say to them?
Look, I'm a physician, and not only I'm a physician, but I'm leading a study to establish if this is going to do what we say it's going to do. What we have is our preliminary data, but we haven't done exactly this study that I'm suggesting to do. And so from my perspective, I don't want people to take it. I don't want it to be part of what people are doing when we don't have that much evidence. And I don't want it to ruin the research that will show that it's doing that. And the major reason is not that I don't believe in metformin, but we have a bigger purpose. And this is to allow a regulation, either by the FDA or wherever it is in England and the European Union, to have an indication that is to target aging, however you want to phrase it. We need an indication because metformin is going to be effective, but we have to get better drugs, combination of drugs, so we can really work on extending health span.
So you don't want people essentially listening to this to have false hope, that you want to see the science take its course.
Right.
That makes a huge amount of sense, because I think people grasp onto things very quickly, and the commercial advertising world, I think, bears a responsibility for that.
It has become a business, but the good thing that works in our favor is that metformin is generic and it's very cheap. And there's no pharmaceutical that is going to push or advertise for that because they're selling enough of this drug for very cheap and it's not going to make a difference for them. So at least the pharmaceuticals are not going to advertise that. It depends when people are listening to us if they understand that we're telling them there's a hope and we're going to prove that. And once we prove it, it's going to get better and better all the time.
What about your own family and speaking from a personal perspective in terms of lifestyle? What inspires you to do what you do?
Well, my family doesn't have longevity. Both my parents died, and it wasn't pretty, the way they deteriorated. So on a personal level, I'd like to have something like that. The lifestyle issue, if that's what you're asking.
Well, essentially, based on what you've just said, the lifestyle issues and the interventions are what would apply to you because it's not in your genetics. Right.
So what I do, I'm pretty sure that I can say that we all agree about that. At every age, when you're younger and when you're older, exercise is really the major benefit for health span. This is the one thing that we know is working in humans and working really terrific.
What kinds of exercise? Because everyone talks about the benefits of walking, which is probably the simplest form of exercise, but there's a lot of research studies recently, especially in the UK, in fact, coming out of Newcastle, about intense, short bursts of exercise that are good for you.
Right, and I have to tell you, this will become apparent. Okay, I don't need to have an opinion about it now. My only opinion is that if you're asking, if people are now listening and saying, we decide to exercise, I would tell them, get a Fitbit or get your iPhone, which has a health thing, and make sure that you're trying to achieve at least 10,000 steps. I think this is a good thing to do. Now, the others have to learn more. I always think that when you combine things, it's better than if you just do one thing. And you need the upper body and you need the lower body and you need the cardiovascular. And what is better or worse, I'm not sure. If you can do a combination of that, I think that'll be great. But let's start by doing 10,000 steps a day.
So it maybe doesn't sound that exciting, but exercise in moderation, small goals to start with, not extreme exercise, not extreme running or weightlifting or whatever it happens to be, but just common sense activity.
Right. And I think with aging, we have to realize, even in caloric restriction, we know one thing: if you give the animals zero food, they're dying, right? So you know that there's just the right amount, of caloric restriction, and I think that's right to aging. Exercise is not something that we thought a decade ago. We didn't think that exercise could really work because we thought that oxidative stress is really the pathology behind everything we're getting. And there's no better way to increase oxidative stress by exercising. And yet, exercise has always been good because it probably increased the defense against oxidative stress more than anything else. So it didn't make sense, but we know one thing for sure: exercise is good. Not too little, not too much. How much? I don't know. Start 10,000 steps a day.
And what about your diet? We've talked a little bit about calorie restriction. Where do you stand on diet? There are so many stories, so many theories about red meat and eggs and cholesterol and dairy, and it goes on, that people are actually quite confused.
They are. So I'm very weak, okay? I'm not going to do, I'm very bad in diet. I love to eat.
You like chocolate?
Okay? I'm a foodie. I'm a cook. I eat everything. I cannot stop eating. So I exercise more. Part of the thing. But
I should say, I'm sitting opposite you, look in good shape.
Well, I take pride in the fact that epidemiological data showed that the lowest mortality in humans is in a BMI of 27, 28, which is overweight. Okay, so that's me now. Okay, you're thinner than that.
I'm about 25.
I'm kidding myself and saying,
so you're in better shape.
I'm better shape than you. We'll have to adjust the age.
But doesn't that just confuse people further? We're all told that the goal is, the BMI is about 25, and yet we're learning recently that, as you say, maybe 26 or 27, a little bit of extra weight as you get older is a good thing.
We need subcutaneous fat. It's very important for infections and for metabolism. So again, you cannot have too little of that either. But let me tell you the problem and why people are confused. I feel so bad for this field of diet. I feel really bad for them because when it started, they had to make some rules, okay? And unfortunately, every assumption turned out to be wrong. And they should have known better, okay? So how did they start? They started, we should eat 3 times a day. Based on what? Who in human history ate for 3 times a day? They got up in the morning, chased the deer, got it at night, and had a kebab at the end of the thing. There wasn't 3 meals a day. And then they said 65% carbohydrates. Carbohydrates, that's also... we were never exposed to so much carbohydrates. Cakes is recent, and sugars are recent. So what happens? And then there comes also the epidemic of obesity on top of that. So what happens? They started making the rule and going back on the rules. And that's what's confusing. Even the dietitians that are learning so specifically what are the rules are frustrated because every year they change. The last change was we have to eat more fat, okay?
Whereas 20 years ago, it was all about fat-free and margarine instead of butter, right. And then it's totally turned on its head now.
So I don't blame people for being confused. I think that the important thing is, as we said with exercise and everything, you kind of have to diverse your food. I don't think that no beef at all is good. I think you need B12 from somewhere and some proteins.
So you wouldn't recommend a vegan lifestyle?
Let me just tell you, in my centenarians, okay, we have more than 620 centenarians. There's no vegan, and 2% are vegetarian, which is maybe less than in the population. Now, it's people who lived in different eras and maybe didn't hear about that, but it's not that we have centenarians who are vegetarians and vegans in crowds that I could say, we're up to something.
Yet we're told recently that there's more and more there seems to be a direct link between red meat, animal protein, and cancer.
Right. And okay, but on every food that we have, there's some story, right, that is coming on. And so I think that's why I'm saying that to diverse the food is good. So we are doing something else. My wife and I have a prenup agreement that if we go to a restaurant, we order different things and switch in the middle. So we don't have too much of a bad thing. And on the other hand, if there are some elements that are important in some vegetable that we have and stuff, we share it. So we are not exposed to too much and we are diversing our diet. Is that good? It's as good as what the dietitian said, but that's kind of my view of what we have to do.
So just like we said with exercise, in terms of moderation, that's essentially what you're prescribing for diet, just moderation, not too much of anything in particular,
right.
and keep it sensible, and presumably not binge eat or any of these extremes that people go to.
Hey, there are lots of literature that says that in the fish that is available to us or to some of us, having more than once a week is a lot of mercury, and there's no food that seems totally safe to eat all the time.
And of course there are other aspects to the environment and the external factors that can affect us on a daily basis. We've talked about exercise and food. There's mindset and there's mindfulness that people talk about a lot. And I'm curious, do you have a daily routine or a morning routine, things that you do every day that nothing to do with food, nothing to do with exercise, but just your frame of mind and how you approach life, things that perhaps you do to reduce the stress of life?
So my answer is right only for me, so I don't want it, but I'm blessed that in the last 30 years, I didn't have the same day repeating itself. Okay? Every day is new things, new challenges, and life is so interesting like that. I mean, there's a lot of stress. I have I have a big organization. I need to write grants. We have this thing. But for me, the fact that I'm here now and everything is a new challenge, it's really also the relaxation, it's the stress, but also the relaxation. And I'm just feeling blessed that I do that. All I have to do when I go every day is to get somewhere where I can exercise and then go out and have good food, not too much of it.
Do you make that as a sort of prerequisite in terms of planning your travel? It has to be a hotel with a gym or a pool or something, or a running course?
Pretty much. I'll tell you, pretty much. If there's no gym, I wouldn't go to this hotel.
I'll tell you something that struck me about you, just meeting you today for the first time. You have a great personality, and you have a great relaxed attitude. And I meet a lot of people in your position, very important, responsible for lots of people. And you sometimes feel the stress coming into the room. It was quite the opposite with you. In fact, we met and went for a cup of coffee before we did the interview. And clearly that's just part of your personality.
Yeah, and I hope, I'm accepting this as a compliment.
It is. It's meant to be.
What my personality helped is to get groups. I'm really the best as a promoter and a leader. And I think that's very helpful for me to get people together, because we cannot do those things on our own.
Well, Nir Barzilai, this has been a really fascinating conversation. Thank you very much indeed.
Thanks. Wonderful being with you.
And I hope you enjoyed that conversation. Before we go, a reminder that on this podcast, we do not give out medical advice. We share and discuss ideas. But if you're considering adopting a new diet or exercise regime, you should always consult your doctor first.